it's covering the title. Move that. There it is. Hey guys, my name is Jay Wilson. I'm a freelance consultant for my company, Onyx Reporting, and today I wanted to do a follow-up webinar on one of the sessions that Andrew Chaffin from Domo and I recorded called Data Science Demystified. If you didn't watch the webinar, I'll post a link in the description. It was pretty fun. We talked about conversations that we have with organizations that are trying to bridge that gap between, let's say, their first year implementation of Domo, where they're trying to just get started with good old-fashioned descriptive reporting, and then transitioning to this state where they can start doing predictive or prescriptive analytics. And one of the things that I kind of talked about in the session was to say that a lot of times our brains just shut down when we hear phrases like data science or regression modeling. It's like this black box mystical thing, and it doesn't have to be. So in this video, I'm going to show you guys how to do a simulation using a use case that I think we all know, love, and is dear to our heart. Well, maybe not so much now that we're in coronavirus season, but during the session, Andrew and I, we talked about that experience of showing up at the airport and having your flight be oversold. And you're weighing that decision. Do I take the travel voucher and take whatever piddly amount of money they offer us to get booked on the next flight, or what do I do? As a frequent traveler, the question that I always ask is, how do the airlines know how much money to give away, how many flights to oversell? And in this webinar, I'm going to actually show you guys how to solve that question. Now, I know all of you guys are not running airlines companies. But this kind of gets into the realm of forecasting and demand planning and solving that problem using simulation. So I hope you'll see the parallels in the use cases that you're tackling. Right. So what did I do? I generated a data set using ETL that conveniently has 100,000 rows, where every 50 rows represents a new flight. And what I've done is I've calculated how many people showed up for this flight. Now, my stat said 95% of booked travelers show up. So you're looking here and you're saying, hey, there were 50 seats available, 45 people showed up. 45 divided by 50 is 90%. So that's not 5%. What's going on here? Well, the whole point of simulation is to say, run this same experiment many, many times and then see what will happen. So I'm running my experiment 1, 2, 3, 4, 5, 6, 100,000 times. And each time I'm getting a new calculation for how many people showed up. If you're wondering how I actually accomplished this, I, in SQL, used, in Magic 2.0, actually. I'll show you guys that in another video. I ran a random function like the Excel RAND that will generate a number between 1 and 0. And if the number is greater than 0.95, that means they missed their flight. If the number is less than or equal to 0.95, the results of the random number, then they made their flight. And so that's just how I ran the simulation. And if I wanted to run it again, all I have to do is run the ETL again and look at my results. But I've done this experiment several thousand times across multiple flights, so I'm pretty confident I don't have to run it again. And that's really the whole point of simulation. And some of you guys are like, I'm about to change the channel, Jay. Tell me something interesting. I promise, we're getting there. So I can demonstrate that my simulation is working by saying, hey, if I run the average on the number of people that missed their flight, I get 0.05, which is in alignment with my beast mode, right? So we know that the Excel function works. And you might say, well, Jay, that's super easy. Take 0.95, multiply it by 50, because that's the number of available seats. That gives you 2.5. That's the number of seats you should oversell. Well, yes and no. Because remember, we're not talking about overselling one flight. We're talking about how many seats to oversell on many flights. And across many flights, I want to maximize revenue. So maybe I want to oversell 3 or 4 or 5 seats to make up for the times where 90% of the people show up instead of 95. And that's where we make that jump between description and prescription. Description says, looking historically, 95% of, on average, 95% of the people showed up. Prescribing action says, hey, based off of the revenue and cost calculation, this is the right number of seats to oversell. So how did I get to the answer? What I did is I built a data set view, which super cool. Going to show you that in another tutorial. I built a data set view that says, hey, for flight number 1, remember that flight that had 45 people show up? What if I oversold 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 tickets? What would be my revenue and what would be my cost if I had oversold that many tickets? And then we're going to run that same experiment for every single flight. Remember, I ran this experiment 50,000 times. Well, actually, I don't know how many flights I have, but I ran it many times. Cool. Step 1, let's just calculate revenue. Well, revenue is total seats plus the number of seats to oversell times, let's assume that I sell my seats for $100 a piece. Easy. Easy math. All of this is going to be easy math because I'm not that smart. Okay, so again, seats oversold plus total seats times 100, that's my revenue. And you might say, well, Jay, to maximize revenue, just sell as many tickets as you can get the suckers to buy. But here's the thing. As soon as you get past 50 seats, all right, as soon as 50 people show up for your flight, that's when you start distributing travel vouchers. And travel vouchers are more expensive than the money you get per ticket sold, hopefully. So let's model travel vouchers distributed. Travel vouchers distributed is going to be seats to oversell plus the number of people that did show up minus the total seats that were available. Let's run that. So let's say you have a 50-person flight, 45 people showed up, and you oversold 6 seats. So 6 plus 45 is 51. 51 minus 50 is 1. You have to distribute 1 travel voucher. Pretty easy. Pop that. Oop, let me put that in the right place. I'm going to put that here. Okay, so, negatives. You can't give out negative travel vouchers. We only give out travel vouchers if this amount is greater than 0. So case, when this is greater than 0, then do the math. Else, you actually didn't fill up your plane. Right? Think about that. If 45 people showed up for my flight and I only oversold 1 seat, that's 46. 46 is less than 50. I didn't actually have to give out a travel voucher. I would only have to give out a travel voucher if I had oversold 6 seats, 45 people showed up, and again, that's the 1. Cool. So what is the cost of a travel voucher? What is that thing we want to mitigate? Well, the cost is the number of travel vouchers. Oh, that should be a case. Sorry. So it's the number of travel vouchers we distributed times however much money you give out per travel voucher. Let's assume we give out $150. So 1.5 times the ticket price. Eyeball that. So here, no travel vouchers distributed. I distributed 1 travel voucher, so my cost increases linearly. Piece of cake. That's beautiful. Now that I know revenue and cost, I can calculate profit. Profit is revenue minus cost. Guys, we're almost there. Stay with me. So now we've got profit, right? No maximum here. Yep. Here's where I incur the first travel voucher cost, and so my profit starts going down between the fourth, fifth, and sixth ticket, which could be eyeballing it. Cool. So let's pare this back. The question we want to answer is, what is the number of seats to oversell that maximizes profit? So let's cut this down and let's say maximizes average profit. Not that I like average, but let's go with it. Okay, so if I oversell one seat, my average profit is $5,000. Okay. If I oversell 3 seats, my average profit is $5,165. And here, between 0 travel vouchers distributed and 1 travel voucher distributed, this is where I start seeing that decline in revenue. Sorry, decline in profit because I'm giving out travel vouchers. Now we're using average, and again, I don't really like average. So let's take a look at our friend, the vertical box plot. Now, friends, I hope you take the time to understand the difference between average versus median and when they're important. Sorry, yes, median. Average and median, or mean and median, and when they're important and when they matter. But the point is like, you look at this graph, you're like, okay, where is the bar the highest? The bar is the highest here at 3 tickets oversold. That's your answer, oversell 3 tickets. And that's kind of in alignment with the math we ran earlier, which was to say 95% of people showed up for their flights. 95 times 50 is 2.5. 95% times 50 is 2.5 tickets. So yeah, it makes sense. 3 tickets is the number of tickets to sell, oversell, that will maximize your profit. But here, guys, this is the part that's going to make you mad about airlines. We did this math assuming that the airlines reimburses you 1.5 times your ticket amount in your travel voucher. What if this number goes down to 125? So only 1.25 times your ticket amount. Actually, before I change that, take a look at the shape of this line. Oops, sorry, I did not mean to filter. Take a look at the shape of that line. Now I'm going to adjust to 1.25. That slope is a little bit less. I'm going to take it down to 110. And that line is virtually flat, which means up to a certain point, probably the 12th or 13th ticket, let's say, airlines are not penalized for overselling tickets as the distance between the distance between the travel voucher and the ticket price diminishes. So the less money they give out per travel voucher, the less it hurts to oversell, especially when there's like the freak chance that I might make these stupid amounts of profit here. Interesting. Now, what happens if this number, this cost, jumps up to $200? Now the decision is very obvious. We want to avoid incurring travel voucher costs at all costs. At the end of the day, like, we don't need to understand how the travel industry works. But what I really appreciate about Domo is, like, with just using a little bit of, it's not even trickery, like, we're just using standard features in Domo. Just by using the standard features of Domo and a little bit of patience and understanding, we can build out a model that will allow us to do a what-if analysis, which is functionally what we've done. It will allow us to simulate different types of behaviors or events, models, if you will, and then come up with a conclusion, prescribe an action. This is the right number of things, right number of tickets to oversell. And if I play with the cost, we can maybe arrive at a different decision. Super cool, super valuable in Domo. And that's, when we talk about building a model, that's what we're talking about. So I hope you enjoyed this session about simulation. I'll do another one where we talk about what happens when different flights have different customer behaviors. So in the webinar that I talked about earlier, Andrew said, somebody flying between San Francisco and LA, maybe they only have like a 75% probability of showing up at the airport. Whereas somebody flying between, let's say, Portland and Frankfurt has a 99% probability of showing up for that flight. And so based off of those two things, you might change the number of tickets you oversell, especially because the cost will get higher on a transatlantic flight for that travel voucher. So yeah, man, I hope you had fun. I'm looking forward to the next video we do on this topic. And then I'll also do another video where I show you the technology or how we built this data pipeline. Anyway, my name is Jay Wilson. I'm a freelance consultant, Onyx reporting. If you need help with your Domo implementation, want to make it better, faster, stronger, want to do some advanced things in the analytics, hit me up.